Okay, Bismillahirrahmanirrahim. We'll have a look at the first question. Okay, so basically this question is looking at how we can determine the relative atomic mass of lithium by measuring the volume of hydrogen. Okay, so then they ask you to draw the apparatus you could use to measure the volume of hydrogen. The biggest hint there is hydrogen will most likely be a gas at room temperature. Okay, label the chemicals in your diagram and show how the reactants can be kept apart until the reaction is started. So you really have to read this part, because if you mix the lithium and the water together, because these are the reactants, lithium and water together, then you will be penalized. Okay, so it is important that you separate the reactants until the reaction is started. Okay, but at the same time, you also do not want to put the reactants outside, because if you put in the reactants and then only you cover the rubber bung, then you are introducing, you are allowing the gas to escape. Okay, so there are two methods or two setups that you can use for the collection of gas. The first one is using a gas syringe. Okay, making sure that all of your setup is airtight. Okay, if your setup is open, then you will lose marks. Okay, so label everything. Like in this case here, this is open, right? So you will be penalized. You need to make sure that it is airtight. Everything is closed, right? So I will have my water here, H2O. Liquid. Okay, now my lithium will be in the conical flask already, but it will not mix with the water. Okay, so I will have a holder here. I know you've not seen this, okay, but label it as a holder, and then this one you label your lithium. Okay, label your gas syringe as well as your rubber bung. That's to make sure that you're closing the top of the conical flask so that the hydrogen gas cannot escape. This is rubber tubing, or you can just write it as tube. Okay, so you can see that the lithium and the water, these two reactants are kept apart. Okay, so when the reaction is starting, at least you don't have to dismantle your setup. You don't have to open. You're introducing air, right? All you have to do is just tilt your conical flask. Your lithium will then fall into the water and they will react and produce hydrogen. So you are not opening, or you're not exposing your setup to the air. Okay, so that's one. The second one is collection of gases via displacement of water. Okay, same thing. You will use a conical flask. Again, you need to separate your reactants. So you have H2O here, and then your lithium and a holder. So you can just choose one, whichever, but you need to be familiar with both. Okay. As for the collection of water, you need a water trough or a water container, and then you need to have an inverted measuring cylinder. Okay, and then your tubing needs to go into the measuring cylinder. Okay, not into the water. If it goes into the water, then you will lose the gas. Okay, so you need to make sure that the gas goes into the measuring cylinder. Okay, airtight. Don't forget your rubber bung. Okay, so just label, this will be measuring cylinder. This will be water trough. And then there's your tube, and everything else should be the same. Okay. Right. What else? Yeah. For 3 marks. Okay. You have to make sure that the lithium is not touching or mixed with the water. Okay, moving on. If you did not finish copying that, please watch the recording later and then you can pause it. Okay, so we want this session to be as short as possible. To successfully carry out this experiment, a correct procedure must be followed. The lithium you will use is stored as large pieces under oil. Okay, so you can imagine lithium cannot be exposed to air or water because it is very reactive. So you have a lithium here and then it is stored inside oil. This first question may sound silly, okay? Beginning with a large piece of lithium being removed from the oil, state how you would prepare a small piece of lithium for use in the experiment, okay? You start with a big one, you want a small one. What do? You cut a small piece. Sounds funny. Yes, it is funny. I find it funny as well. Cut a small piece and remove the oil. I mean, that should come without any instruction, right? It should be it should be obvious. Okay. By only observing the gas collecting apparatus, state how you would know the reaction had stopped. So gas collecting apparatus, if we look back to the drawing, our gas collecting apparatus is either the gas syringe, okay, or the measuring cylinder, right? So we are not looking at the conical flask where the reaction is happened, not there, right? So you cannot say when the bubbling stops, because bubbling will happen, well, you probably can, but bubbling will happen here. So how do we know, based on the gas syringe and the measuring cylinder, how do we know that the reaction has stopped? Is when the level stays constant, okay? The volume stays constant. So that means there's no more additional or any more hydrogen gas being produced, okay? So to answer that, no change in volume, okay? Other accepted answer that I don't really fancy is no bubbling in the syringe and the measuring cylinder. Okay, sometimes you see bubble. If you have carried out this experiment, you would see last time, especially in the setup, there is bubble here. Okay, but not observing the bubble in the conical flask. Other accepted answer is no more gas collected. I mean, yeah, that should, but how do you know no more gas or no more hydrogen is collected when the level stays constant? Okay. Other than eye protection, state 2 precautions you would take to make sure the experiment proceeds safely. So obviously it has something to do with your skin, okay? Your skin cannot come in contact with the lithium because of its lithium is corrosive, okay? And may cause burn. So you would wear gloves. Some of you may suggest wearing lab coats. They fall under the same point, okay? Avoid skin contact, wear gloves, wear a lab coat, or use tongs instead of your hands to touch the lithium. They all fall under the same point. So 1 mark, okay? The second one is to keep the lithium away. Keep lithium away from water or fire, okay? And another accepted answer is to ensure that lithium is returned to the storage vessel under oil. I mean, of course, right? If you're done with the lithium, you would put it back to the container where you store it in the first place. Okay, next is the calculation bit. So the AR of lithium is 7. The volume, the volume is what we want to find out. The mass of lithium is given, okay? So mass of lithium is given as 0.1 grams. So now you know the mass and you know the AR, so you can find the number of moles of lithium, okay? Mass over AR, right? But we're not interested in the lithium, we're interested in the hydrogen, okay? If you know the number of moles of lithium, you can find the number of moles of hydrogen by looking at the relationship that lithium and hydrogen is 2:1, okay? So the number of moles of hydrogen would be half, okay? Half of your lithium, just lithium and hydrogen is 2:1. Half of the number of moles of lithium, but that doesn't end there. They want you to give volume, okay? Volume, to find volume of hydrogen, you take the number of moles of hydrogen times 24 dm cube, okay? And then you will get the volume of hydrogen produced. The answer would be somewhere around, hold on, let me just get my calculator. Okay, so it will be around 0.171 dm cube, right? Double check your calculation again later. What would be the capacity of the gas collecting apparatus you would use for the volume of hydrogen produced? Okay, so 0.171 dm cube is equivalent to 171 centimeter cube. So this is where your knowledge of the apparatus in the lab comes into play. Okay, in the exam you will not be in the lab, so you wouldn't be able to look around and see what apparatus are available. So you have to be creative, not creative like making up your own apparatus, but you also have to remember if this apparatus exists. Okay, so if your gas is 171 centimeter cube, you would want to use a 250 centimeter cube of measuring cylinder. Okay, or there is 200 centimeter cube of measuring cylinder, or even 500 centimeter cube. Okay, depending on what your setup is. If you use a syringe, then you would use a 250 syringe or a 200 syringe or a 500 syringe. Okay? If it's measuring cylinder, then it will be measuring cylinder. My point here is do not choose an apparatus that doesn't exist, like a 170 measuring cylinder. Okay, so there's no such thing as 170 centimeter cube cylinder. They come in nice number, like it ends with 0 or it ends with 5. Okay, but so far you can see these are like the common ones. Not that you probably have not used the 500 centimeter cube, it's a big one, but as long as it looks sensible. Okay, next is another method where titration is happening. The titration of the lithium hydroxide. Okay, so first you take distilled water and then you add lithium. So this is where lithium hydroxide is being produced, lithium plus water. How do I know that? You go back to the equation here, lithium plus water, you will get lithium hydroxide as well as hydrogen gas. Okay, so after you form lithium hydroxide, that is when titration happens, because lithium hydroxide would be a base. Okay, base can be titrated with an acid. And if you know the concentration of the acid, you can find the number of moles of the acid, then you can find the number of moles of the base. Okay, so that's how titration works. State how you would accurately measure the total volume of distilled water in step 1. Now, accurately, if the word says accurate, one thing that you should know is beaker, measuring cylinders, they are not accurate. Okay, all the syringe, dropper, these are not accurate. The only accurate one is pipette or burette. Okay, so state how you would accurately measure the total volume of distilled water. Well, you can choose to use a burette or a pipette. You know burette that you use in titration is 50 centimeter cube. You need 100, so you will say use a 50 centimeter cube burette twice. Okay, there is also a 50 centimeter cube pipette, but this one you have not met before. You've only been using the 25 centimeter cube pipette. But again, as I said, they're a nice number, like 25, 50, 75, not so much. 100 centimeter cube of pipette, yes. 150, I don't remember seeing it. And then 500 is the safest. Okay, so you kind of have to be familiar with this apparatus that exists. State how would you know that the reaction between lithium and distilled water was complete. Okay, so this time you do not have that setup. You're no longer collecting the gas. So what you will see is water, and then you have lithium. Okay, so lithium with water will what do you say? They will react with each other, okay? And then hydrogen gas will be produced, lithium hydroxide will be produced. You won't see much difference happening because lithium hydroxide is colorless, okay? But what you can observe and how you can tell that the reaction has completed is when you no longer see the lithium, okay? When the lithium disappears, that's when you know for sure that the reaction has complete. So it's when lithium solid has all reacted or dissolved completely. Okay. State how you would transfer 25 centimeter cube of the solution of lithium hydroxide into a clean conical flask. So basically, after this reaction happens, this one here, after it happens, the lithium has already dissolved. So I will try to draw the lithium dissolving. Okay, so lithium is in there, and then you want to transfer it to a conical flask. And because this is titration, you want to be as accurate as possible. And you know, for titration, when you need 25 centimeter cube, you would use a pipette. Okay. State how you would ensure that your titration result was reliable. Okay, so I think most of you would say repeat titration because that's what you use. But to get a full mark on this, you cannot just say repeat the titration, but you must repeat the titration until values or titers are within 0.1 centimeter cube. Okay, I never tell you to repeat because, you know, I just ask you to make up the number. Okay, so you do not repeat the titration until you get the exact same number. You are just wasting your time. Okay, with titration, they give you allowance. 0.1 centimeter cube difference is good enough. Okay, so this is something that I always remind you as well. Moving on to D, to make sure that the beaker and the conical flask used in the experimental procedure are clean, a student decides to wash them out with some distilled water before starting the experiment. Okay, so you have two things here, beaker and the conical flask. Okay, beaker is this, not involved at all in the titration, and the conical flask is the one that is involved in the titration. Okay, so this one requires a little bit of thinking. So some water remains in the beaker. Okay, so say the student has washed the beaker beforehand, and then there's very little water, like, you know, very little, I would say 1 centimeter cube. Okay, this student did not completely dry out the beaker, and then he added 100 centimeter cube as following the instruction, 100 centimeter cube. Okay, so then 100 centimeter cube of water, and then only he added lithium. Right now, he would have thought that he only had 100 centimeter cube of water, but actually he has 101 centimeter cube of water. Okay, so this means that this solution is diluted. Okay, because there are more water, more volume than we expect. Because I would have thought, oh, there's only 100 centimeter cube of water, but because of the washing, yeah, this small 1 centimeter cube can make a lot of difference. Okay, so what happens is that because this is diluted, this solution or the concentration is diluted, that means concentration goes down. Okay, the concentration is lower than expected, right? If you just imagine you have a certain mass out of 100 centimeter cube versus a certain mass out of 101 centimeter cube. Obviously, the one with the extra water, 101 centimeter cube, makes your lithium become more diluted. Okay, so as concentration decreases, okay, concentration, the formula is number of moles over volume. Okay, your concentration decreases, your number of moles also decrease. Okay, number of moles is mass over AR. If your number of moles is decreasing, your AR would increase. How do I know this? Because the relationship is inversely proportional. Okay, concentration go down, number of moles go down. They are directly proportional. But for number of moles and AR, they are inversely proportional. So if one goes down, the other one goes up. Okay, so to answer this, the AR would be larger than expected. Okay, bigger than expected. Where's my... Okay, this one. The AR would be larger than or bigger than expected. Okay, so the reason for this is the solution is more diluted because of that extra water. It's not much, but it does have effect on the calculation later on. Okay, why am I talking about AR? Because that's what the question is asking about. The question is asking, would this have any effect on the calculated relative atomic mass of lithium? Okay, explain your reasoning. So that's the first scenario. The second scenario, some water remains in the conical flask. Okay, so this is water, again, 1 centimeter cube, maybe. Okay, versus if you did not have water. Okay, right, so this is washed conical flask, and this is unwashed conical flask, dry conical flask. Okay, before the start of the reaction, of course, you take 25 centimeter cube. Okay, 25 centimeter cube of this liquid here. Okay, you put it in 25 centimeter cube of lithium hydroxide. And also, if you compare this to the other scenario, 25 centimeter cube of lithium hydroxide. Okay, so the question is now, will this, the fact that there is some water in the conical flask, will it affect the calculation or not? The answer is no. Okay, why? Because you see, you are taking 25 centimeter cube of lithium hydroxide, 25 centimeter cube of lithium hydroxide. Even if you put that in, okay, the number of moles are the same. There is no changes to the number of moles. Concentration will change, but not the number of moles. Okay, and we are interested in the number of moles of lithium hydroxide because that will help us. Usually, we're only interested in the number of moles because using the mole ratio, we can find the number of moles of the acid. Okay, and we can find a lot more from there. So the answer to this question is no, no effect on AR. I don't know if you remember, but when you do your titration, when you did your titration last time, I told you that you can actually use the distilled water to wash the sides of your conical flask. Okay, this does not change your reading, even though the concentration is become diluted, but the number of moles of lithium hydroxide that is already in the conical flask stays the same. So you're not changing the number of moles. Okay, so no effect on AR. The reason is because the number of moles of lithium hydroxide is the same, with or without additional water in the conical flask. Okay. Okay, so that's question 1 done. For question 2, for tomorrow, I would like you to have a read, okay, and as usual, prepare your values, okay, calculate them, and please make sure that you follow the instructions. Standard form to 3 significant figures. Standard form means like this, times 10 to the power of negative 3 or times 10 to the power of negative 4. Okay, so that will be your task today, and make sure it is to 3 significant figures, and then log 10 of 1 over t to 2 decimal places. Okay, once you have calculated this correctly, then you can start plotting. Okay, and then you will tell me how your graph looks like tomorrow, because I am not going to plot it tonight. So I believe that your plotting is correct, and thankfully you don't have to worry about the scales. Okay, the scales are already given for you for paper 5, right? So you should not make any mistake here. The plotting bit shouldn't be a problem. Okay, so tomorrow we'll continue with question 2. Is there any questions so far? Anything that you did not get from question 1, or anything that you would like me to explain from question 1?
Not really.
No? Everything is okay for you? Can follow, ah?
Yes.
Okay. Right. So if you don't have any questions, in that case, I will end the session here. Okay. Assalamualaikum warahmatullahi wabarakatuh. And thank you, everyone. I'll see you again